Good morning and good afternoon, ladies and gentlemen. A warm welcome to this joint webinar organized by Baumer and Universal Robots. I am Irene from Baumer, Singapore, the host of today's webinar. First of all, I would like to thank you all for finding times to be here with us today. Just to check, can you all hear me well? There's a checkbox at the bottom right. Maybe you can key in your comments. Okay, great. Let me walk through the agenda with you all. This morning, we have speakers from Baumer and UR to share about how VeriSens vision sensors and collaborative robots, short called cobots, can provide one solution application on vision-guided robotics. Q&A and survey will open to all after the presentation ends. A recorded version of this webinar will be sent to your registered email address after the webinar. Before we start the presentation, I would like to introduce both our speakers. Our first speaker is Lee. He joined Universal Robots in 2016 and is based out of the regional office in Singapore. As the head of Southeast Asia and Oceania, he is dedicated to providing innovative business solutions that transform business across the region. With a wealth of experience in the technology, automation, and robotics industry, with a focus in engineering, sales, and marketing, X has deep understanding on how automation and robotics can effectively and efficiently be integrated into business with minimum disruption and for maximum business results. Our second speaker, Augustine Goh, he is the head of the sales in Baumer, Singapore. He has over 10 years of experience in factory automation. He has led product management and sales function in Baumer for several years. Over the last 2 decades, he has implemented various vision-related projects across various industries. With his extensive knowledge in vision sensor products, he has helped to enhance our sensor solution offer and strengthen success for Baumer within the industrial market. So without further ado, let's welcome our first speaker, X Lee.
Thank you, Irene. Hi, everyone. I hope you are healthy and safe. So I'm going to share with you the benefits of easy control together with vision systems on the new E-series collaborative robots over here. So I'll focus a bit more on the collaborative robots, and Augustine will share a bit more on where the vision system can come in to work very closely on the collaborative robots. All right. Let me turn off the videos so that we can have a better bandwidth over here. So my name is X. I'm responsible for Southeast Asia and Oceania. So I believe most of you are in this region. So if you have any inquiries, feel free to drop me a message or an email. I will be able to respond to you. All right. So I'm going to share a bit more on who are we as UR, and then the key benefits on UR collaborative robots on E-series and the product lineup. And then we're going to focus a bit more on the UR Plus, especially on the vision systems over here. Okay. So who are we? Universal Robot is a Danish company. We are the collaborative robots pioneers as well as market leaders today. So today we sold or deployed more than 54,000 collaborative robots worldwide. We have probably more than 50% of market share in collaborative robots world. All right, and we actually started the company in 2005 and start to actually deploy the first collaborative robots in the market at 2008. So when I talk about collaborative robots, right, of course the collaborative terms that the robots is able to work very closely with people. And that is one of the core benefits about the collaborative robots. Because at the past, when you work with industrial robots, they are usually fenced up and people don't go into their workspace and they are not able to collaborate with people, right? So beside that, you are also have other pillars on safety features. The robots are very easy to set up. We make it as simple as possible. You can imagine you can set up the robots in 30 minutes. It's very flexible and it's very easy to program. And all these core pillars are strengthened by the E-series. So the key benefits of the UI over here is very easy to set up. As you can see, the robots over here, they're actually pretty small in footprint. They are very easy to set up. When we deliver in 2 boxes. One comes with the arm. The other boxes will contain the control box as well as the teach pendant. And you're able to set up the arm as well as the control box very easily by connecting a few wires, power cables, and as well as putting up the end effectors together, and you can actually set up it very fast, right? And in today's environment, we're talking about flexible deployment and redeployment, right? You can see on the second pictures, we have a robot that's able to mount upside down. And our robots are actually able to mount at any angle. And you can actually have it on a wheel cart that can actually push around to a different workstation to do different jobs by programming them or configure them. So that helps in today's high mix, low volume programming environment, so that you can actually redeploy from one product line to the other product line, right? So programming perspective, our programming environment are much easier. It's drag and drop kind of functions that you can pull the instructions from the library, and you can actually move the robots by hand guiding to the position you want, and you save the position. You're able to program it very easily. We do see an operators is also able to actually program the robots by going through the training on UI Academy we have, and they're able to learn and deploy the robots by themselves. So in Singapore, we also have some of the local enterprise. They have their own engineering team, technicians that actually deploy robots by themselves, right? That's how easy we can actually program the robots. Of course, the robots are collaborative and safe. So people can have a little bit more flexible to actually go to the robot environments. The robots actually have a force detections. Whenever exceed the safety force you are actually set, the robots will have a protective stop over here. All right. So we built the new E-series for the future to deliver more capabilities as well as product enhancement. And today's topic on UR Plus is actually one of the major capabilities that we have, so that we prepare the E-series robots to do a bit more with integrate with different kind of products, UR Plus products that we have on the platform. I'll share with you a bit more on UR Plus later. Right. So a little bit on the robotics specs itself, you can actually see the robotics arm are very curved and rounded. That is part of the safety requirement. It does not have sharp edges. So the robot's arm come with 6 axes articulated. Every areas that you can actually see a blue caps over here are motors and drive, and each one is 1 axis. So it have a built-in force torque sensor at a tool arm over here that you can use it to sense, like how we sense the products or sense things with our hands. And it have a safety function, 17 safety function that is available for you to use and configure. All right, and all these safety functions are certified by TÜV and is compliant to ISO 13849-1 and Cat 3 PLD. All right, and in terms of maintenance perspective, we actually make the robots in a modular form, so you can actually replace the joint very easily. So take example, if let's say you want to send a joint for repair or replace a joint when there's a wear and tear in the gears, right? You can actually remove just one of the joint and replace with a new one, and you can send the faulty or worn joint back to our repair center for repair. Okay. So on programming perspective, we also have a teach pendant that have an intuitive program flow. You can actually program it very easily by attending our UR Academy, and the UR Academy is actually free online for you. So if you're at home today, if you want to learn about how to program a robots, you can actually go to our UR Academy website and learn how to program a robots on UR platform. All right, and we also have a simulator, offline simulator that is available for you to train how to use. You can download on your computers and learn how to use the robots before you actually deploy the actual one. All right. So I just want to show you the E-series family that we have. You can see that we have a range from a 3 kg all the way up to 16 kg payload robots, and they are all looks very similar from small brothers on the 3 kgs to 10E that we have. But the only difference is they handle different payload, and they have a different reach for different applications and requirements that you have. All right. So the 3 kg payload, UR3E have a 3 kg payload capabilities, usually used in small constrained cases, and sometimes it's also used a lot with OEM, especially in electronics firm. Take example, if you want to do a small PCB gluing applications, you can actually have the robots installed in one of your machines to do gluing applications. All right. Footprint are rather small, and the arm itself is only 11 kg. It's very lightweight and very easy to deploy. All right. The second robots we have, which is also longest in our product lines, is the 5 kg payload robots, is UR5E. It has a reach of 850 mm. It actually has also a lot of deployment of 5 kg payload robots in the market today, right? And today we also have the most heavier payload robots we have on the 16 kg payload robots, ideal for heavy payload lifting up to 16 kg by taking into consideration of end effectors and center of gravity. Application that is ideal, it could be used to do a CNC machine tanning applications, pick and pack products, case packing that are ideal for UR16E, and it has a 850 mm reach for the robots arm. Right, the longest reach robots we have is UR10E. You can see there's a differences between 10E compared to the previous model. The numbers represent the payload. But recently we do an upgrade on 10E robots. It comes with a 12.5 kg payload robots, 12.5 kg payload, and it still has 1.3 meter reach that is able to do palletizing applications. To carry more heavier, you have 2.5 kg more. The price is same compared to the previous 10 kg payload. So today, when you get a UR10E, all the robots come with a 12.5 kg payload. Okay. So also understand that I think today our audience, a lot of you are OEMs, machine makers as well. So I would like to share with you, we also have a range of robots that is suitable to use by machine makers as well as system integrators if you want to integrate our robots into your machines and panel. So these are available for you to use. The difference between the standard robots and the OEM version are such. So the arm, it looks the same. The standard robots come with a control box, and it's higher IP ratings, and it's available on all the robots and come with touch panel as well. And as you can see, the configurations are different between the OEM with either AC or DC over here, which have a smaller footprint, lighter weight, that you're able to install into a control box you have or AMR that you have in your systems, right? Where it's going to use on the AC and DC versions that we have over here, just to give you ideas on where it's going to be used. AC version usually are installed together with machines that usually stationary, and you do not need a big control box. You can actually have the OEM AC controllers integrate into the panels that you have already built for your systems, right? Some of them also use it on a mobile platform that they will require AC input, but they do not want to have the bulky control box, and they actually have their own control panel. They can also have the AC controllers, all right? And we also have a DC controllers that is available, mainly targeting the AMR market, to have a robot's arm mounting on top of an AMR like this that you see in the picture, right? So this is very common, and we work with several AMR makers in the market to actually make this as an OEM solution and bring it to the market. Okay. So here comes the main topic about Universal Robot Plus, and this is one of the very unique platform that you all have. Why we actually have this is because we are very much focused on developing the manipulators that you can see over here. the collaborative robots arm, the technology around the collaborative robots, right? But the collaborative robot don't work by itself. We'll need vision, example like eyes. We'll need grippers like your hand to be able to do an application, and that's what user want, right? So what we have on this platform is just like app stores you have. We create a platform, we recruit proven solutions from the market, and we actually work very closely with them to actually certify their product, not just in hardware, also in terms of software on the URCap that I'm going to share later, that is able to integrate very well into UR programming environment. And that makes a one-stop solutions and one-stop programming areas that you can actually program UR as well as UR Plus component in the same platform. All right. So all the products that is recruited into UR platform is certified, is tested, is approved by Universal Robots, and we want to ensure this setup is very simple. Kind of plug and play kind of applications that you can actually build it very easily and can program it directly from the polyscope. All right, that result in very fast, smooth, and low integrations for OEMs, system integrators, sometimes for end users as well who have engineering capabilities. All right. So if you go to your Plus platform, you'll be able to see there's two major components segment we have. One, we are very much focusing on the component itself, which example you have a grippers, right? That is a component. Slowly, we also develop and evolve into building an application kit that is very easy to use and very easy to integrate into an application. Example of palletizing applications over here. Okay. So some of the example that you can see over here on your Plus component and application kit can be a very simple, quick connect, quick release kind of adapter. Grippers over here. If you want to add an additional axis so that the robots can actually travel from one machine to the other, so that we can expand the reachability of the robots, we can add a 7-axis on the robots over here. So that you can attend 2 machine, 3 machine, and we also are able to do polishing kind of applications over here, right? So not all the components are having a software example. Some of the components that are purely mechanical, example a protector for a hitch pendant is also available in the UR Plus platform. Okay. So today we're going to share a bit more on how vision guided will be able to help robotics to do more jobs by equip them with vision systems. They are able to do more things, and Baumer Solutions over here is UR Plus certified, and they are able to integrate very well with Universal Robots, right? Augustine will be able to share with you a bit more on what is functions available in the Baumer Vision Solutions. All right. So Baumer have also created a URCap. This is what I mentioned about the plugin, software plugin that's available by a third-party software into a UR environment like you see over here, right? And they are able to configure the vision systems over here by Baumer, as well as you are able to actually drag and drop this function that is available in URCaps, and you can configure the vision systems by using a UR polyscope environment, right? Augustine will share a bit more on how you can do that in a while, all right? I will not go into details on that. All right, so I'm going to share a simple applications over here that you can see how you actually run applications over here, right? So these applications also come with a URCap applications over here. So it does actually do a more proactive kind of safety or enhanced safety functions we have with the safety scanners. So when someone approach the robots is able to slow down compared to the normal speed that they have. Right. This is one of the applications that you can actually use URCap solutions. But where vision come into places, currently the robots are actually picking from one conveyor and do a pack into the other conveyor. But imagine if, let's say, you have a product that's actually randomly putting on these conveyors, then we'll need to have vision systems and sensors to be able to tell the robots where the part is, and equipped with a template or library that we have on conveyor tracking. We're able to pick the products from the conveyor and place them on the other conveyor or pack it on the other side with the integration on some other UR Plus component that we have over here. Okay. All right, so just a short introductions. If you have any questions, feel free to put in the chat and I will be able to answer that later. All right, thank you very much. And if you have any questions, feel free to reach out to myself. I'll pass to Augustine for the sharing on the vision systems. Thank you very much. Over to you, Augustine.
Good morning and good afternoon to everyone present in this webinar. I hope you have enjoyed and the sharing from each. So I'm the second speaker for today, and my name is Augustine, as introduced by Irene earlier. So without further ado, I will go into the juice of this webinar from the vision-guided robotics. In terms of contents, we'll be covering into the introduction of Baumer, so that everybody can have an understanding of who is Baumer. And I'll talk a little bit about the vision-guided robotics, the history, and also what are the challenges faced by the system integrator when they integrate the visions with the robots. I will talk about the benefit of using Baumer URCap solutions, share some application examples, and last but not least, I'll do a summary and a recap of what I have just talked about for the next 20 minutes. Baumer is a Swiss company. We are located in Frankfurt, so we are about 1 hour ride from Zurich's international airports. And Baumer is located in 19 countries, over 39 locations. And some of those pictures that you see are actually the pictures of our factories. In terms of Baumer portfolio, Baumer actually is a sensor solution providers. Baumer have the proximity sensors, the measurement sensors, the advanced sensors, the force constraints, the process sensors, the encoders, the industrial type, the heavy duty type, and last but not least, also the industrial cameras, the vision solutions. So you can see the scope of what Baumer can offer. A little bit history on the robotics and the vision, the smart cameras. So the robots way back in the 1400s, we thought about robots at the time. So you cannot imagine 700 years ago. So the development of robots come in only somewhere in 1961 with the robots Ultimates, okay, by GM. And along the way comes the vision, the smart cameras, the first integrated vision. So the optics together with the processing unit, it was invented in 1981. Okay, the first industrial cameras was launched by Sony in 1986. And Baumer actually launched the VeriSens in the year 2005. This is our Gen 1 VeriSens. And as what each have shared, the UR robots, the UR5 was launched in 2008, and the cooperation between Baumer and UR was started in late 2019. So Baumer view the industrial automation world of tomorrow. Okay, I show in the graph the implementation, the adaptation of technologies from the I/O link of the sensors to the fuel bars to the automation, the SCADA, all the way to the clouds. So today, the focus is more onto the smart visions and the robotics. Baumer hear from our customers, the voice of our customers, various points, some of the pains and some of the needs. In terms of the setup of the vision sensors with the robots, we hear the feedback of the difficulty in setting up using different software platform, having to toggle between the two platform multiple times during the setup process, the difficulty in doing the alignments, the calibration, the reference point between the cameras and the robots, or the difficulty of having a 2D camera system working in the 3D space. Why 3D? Because you have X, Y, and Z axis on the robots. And in certain application, we also encounter the optic distortion due to the viewing angles. We also hear the difficulty in the mountings and also the non-standard setup between stationary objects and moving objects. We also have the difficulty of handling multiple objects at the same time. And last but not least, also the technical knowledge of the engineers that doing the setup. So ideally, what does our customers want? In ideal cases, one software, all the robots and the visions, everything in one software. And you throw in AI, artificial intelligence, and voice recognition, and self-teaching. You just need to power up the robots with the cameras. It will work by itself. I mean, that is the ideal case. Of course, that's not possible today. Maybe tomorrow, yes. Okay, so what Baumer offers it with our partnership with UR Robots as a UR Plus certified supplier. As what each have mentioned earlier, there will be a Baumer apps that is to be installed into the UR platform. So together with the VeriSens application suite, so there are only two software to be used during the setup. So firstly, the VeriSens will be set up using the VeriSens application suite. In terms of the recognition of the object, prior to that, we talk about the lens distortion, the configuration of the VeriSens to link up with the UR robots, and some other parameters. So once you do that, you can switch over to the ER robot polyscope software. Okay, as you can see, this is the view, and you can start to do the vision robots alignment. And once you have done that, plus a few other procedure, you are ready to go. So you no longer need to toggle between the vision software and the robot software multiple times. So everything is in sequence, and actually just 2 simple steps. So this offer the advantage, easy to set up, and because of the synchronization of the step, harmonization of the procedure, the technical knowledge of the engineer for the setup is greatly reduced. And because of this synchronization of the setup, it achieves high accuracy, and a lot of steps is being automated. And together with the Baumer VeriSens capability, it offers full inspection capability, including of code reading, and 1D code, 2D code, OCR. So instead of me talking about in details, let's use the video to show you about, in a few minutes, how the ease of setup.
Thanks to VeriSens vision sensors, vision-guided robotics for reliable and quick pick-and-place of unsorted objects has become easier than ever before. We show you how, making all manual hand-eye calibration superfluous. The robot in our example carries VeriSens and is already in position for image acquisition. Vision sensor, PC, and robot are interconnected. VeriSens is configured via Application Suite. VeriSens corrects image distortion in real time. For doing so, the vision sensor focuses on the intelligent calibration target Smart Grid. Just one click will teach and activate distortion correction, which allows for precise tracking of object positions. Unlike two-dimensional vision sensors, robots operate three-dimensional. VeriSens is capable of scaling the X and Y coordinates to align with the selected Z coordinate. A simple 3D rotation of Smart Grid is sufficient for teaching VeriSens its 3D position, which is basic for coordinate transformation. When completing the setup, the VeriSens communication is adapted to match that of the universal robot. Next is setup of the image processing job to enable object tracking in the vision sensor for coordinate transfer to the universal robot. First step, enter height Z in coordinates. Next, select the appropriate feature check. In the example, it's find object positions for contour-based identification of several objects in parallel. A small logo indicates coordinate transmission directly to the robot. These coordinates being the only data transferred eliminates the need for interference configuration. In the final step, VeriSens is activated along with saving the job. VeriSens URCap has already been installed via USB stick in the robot controller. Step 1 explains how. Second step is selecting and connecting the configured vision sensor and also saving the current robot position. Step 3 is only required for image-based coordinate approach, as in the example. If all settings are correct, the LEDs light up. More settings are application-specific. The last button is for call up the coordinate alignment. SmartGrid requires only few linear and rotational movements to ensure a good calibration quality without the usual hassle of multiple error-prone and manual calibration by probe tip. Now it comes to robot programming to ensure reliable pick and place of objects. New command VeriSens job execution is for image acquisition and retrieving results. VeriSens waypoint and move is for coordinate approach via image-based waypoint. Offset values enable deviations from the coordinates delivered by VeriSens. For example, to approach another height. A template is available for complex tasks. For the test run, a new object is positioned in the image area, which is being picked by the robot as expected. Only a few minutes, and VeriSens has given vision capabilities to the robot. This opens up almost unlimited opportunities, including integrated quality control and part identification. Vision-guided robotics, thanks to Baumer, easier than ever before.
I hope everybody can understand the videos, and you can see the number of steps required, the ease of setup using Baumer VeriSens with the URCap software when setting up the UR robots. So it's no longer the previous years of taking hours to set up the robots together with the vision system. If we move to the applications. In terms of applications, it's actually cover various industries, like in the packaging, in the F&B, in the automotive, electronics, assembly, material handlings, or other industries. it's very common to see vision-guided robots applications. So in terms of application, we can break down into two types. One is fixed camera base. As you can see here, the camera is fixed mount, and then the ER robots here will be picking up from whether the beam or the conveyor and place it into the machine, into the chip. The other is the fast mount, where the cameras are actually mounted together with the UR robots. So it provides the flexibility to view the objects from various angles or to cater for different size of object based on the robot controls of the working distance. So in terms of application, we can classify them under product assembly. So in the factory floor, where it can be just the robots itself doing the assembly, or in terms of cobots, the operator is working hand in hand together with the robots in the assembly lines. The other application is on the material transfers. So that's actually where the bulk of the application is. In terms of sorting application, so the robot actually pick either from the tray, from the beam, from the track, and sort out the objects, whether based on good or NG, based on color, based on different product type. Then you have the placement, alignment, stacking type of applications. Okay, the loading, unloading, whether it is in the machine together with the robots. The robots will load the material into the machine, and at the end of the line, the robots will unload it from the machine to the conveyor or to the pallet. So also we have the removal and placement, like application where the injection molding machine, with the support of the robots to retrieve the finished product from the injection molding and place it onto the conveyor or onto a tray or jig. And we also have the getting popular transport, where the robots can be mounted onto a autonomous vehicle, so they can actually transfer the products, like a wafer, a cassette of wafers from one process line to another without the need for an operator to do manual transfer. So in the material handling, it's very common. It's either the robots, vision guided robots is working within the machine environment, picking from the conveyor. The other is maybe from the pallet. And in terms of the objects, it varies from the plastic, medical, electronics, like the lead frame, the wafer, the IC chip, to the automotive parts. It can be anything. So this is an example of a Baumer success story. Because of the sensitivity, so we are unable to really share the actual image of the projects. So the image are for illustration as a substitute. So the customer like to retrieve the objects, and the objects come with various diameters in a stack. And you want this to be done automatically, the sorting from the stack. In this solution, the UR10E is used together with the SC900. So the SC900 is a C-mount type with higher resolution, so that allow to cover a bigger field of view or to detect the smaller objects. So the robots with the VeriSens on board will do the position check of the objects. So the VeriSens will detect and feedback the position coordinates of the objects. Together with the distant displacement sensor, here is the OM70, where it is used to feedback the height of the stack. So this allowed the robot arms to pick precisely at the correct height, and based on the coordinate feedback from the VeriSens. So the product illustration can be this type of plastic with different size, different color. So the robots, together with the onboard vision and the distance measurement sensors, help to automate this pick and place process. In summary, with the selection of a UR robot together with Baumer VeriSens solution, this offers ease of setup. That's two simple steps from the application suite, followed by the robot software, the polyscope. With the Baumer Smart Grid, this intelligent calibration target helps the user in order to do a one-step image distortion, as you can see in the video. The barrier distortions and those other distortions can be corrected automatically, just one click of the button. And you do the real-world coordinate system, converting the pixels into micron or mm, and align the 0, reference point with the robots. Of course, also you can do the Z-axis calibration step that's allowed the VeriSens to have a better accuracy even when the objects is of a different height, and also or viewing from a slightly different angles, or the picking of the object is actually not on the same plane as the viewing angle of the cameras. So the smart grid actually play an important role to make the whole setup and easier, and also the whole solution more automated and more accurate. Together with the powerful software, the FetchLog, where it helps to robustly detect the objects and feedback the coordinate system, not only one object, but can be multiple objects at the same time. So without the need to customize the communication between the VeriSens with the UR robots, all the objects coordinate XY and angle will be sent to the UR robots, and the UR robots will be able to pick all the objects that is being scanned or detected by a vision system subsequently. And last but not least, the powerful tools from the VeriSens. There are 22 tools available from the various part locate features to the various geometry and inspection tools to the identification tools. So the VeriSens offer a complete inspection detection capabilities. So it enhances the vision guided robots. Apart from just doing pick and place and alignment, it also offer basic inspection to help the customers check the quality, check the dimensions, make sure that the correct parts are being loaded in one solution, in one cameras. Okay, this is my last slide. So I would like to share that Baumer as a sensor solution provider, apart from the VeriSens, the smart cameras, and we also have the profile sensors that can also be worked in junction with the UR robots. We also have solutions for the end effectors, how the various sensor can help to enhance the effectiveness of the end effector, the grippers. And for those who are interested in the write-up, Baumer have a write-up on these URCaps that's available in our websites. So I will end my presentation, and thank you for your attention. We welcome questions, so feel free to key in the questions in the chat box below. Irene, pass to you.
Thank you, Ix and Augustine, for the great presentation. Let's move on to our Q&A session. If you have any question, you can type in your question at the chat box, bottom right. We will try our best to answer them. Okay, someone is typing. Just give me a while. I will flash out the question on the screen. Okay, we have one question. Augustine, you may like to answer this.
Okay, where do we buy the Baumer solution from? Okay, so depending on where you are located, you can actually look for Baumer appointed distributors. If you are not sure, you can actually drop a mail to Baumer Singapore. You can go to our website, click onto the inquiry, drop us a mail directly, and we can actually direct you to the distributor in charge of your territories to support you in your inquiries. You can send your inquiries to sales.sg@baumer.com. You can see in the chat box.
Okay, someone is typing also. Yeah, feel free to key in the question at the chat box. We will try to answer your. Just give me a while. The next question. Do Baumer and UR have the food grade solution for this kind of solutions?
Christine, you want to answer first, or I start first? Kevin, your robots is not food grade certified at the moment, but we do have some solutions in some food handling process, but it's not directly in touch with the robot. So we'll have the any factors that is food grade. They use food grade material, and it is able to actually work on handling food related products. So our robot is not washed down, does not have the wash down capability. In some of the solutions we work on workaround solutions to actually have a food grade sleeve to sleeve down the robots if it's required. Right? Over to you, Agustin.
Okay, thank you. Okay, for Baumer, the VeriSens actually come with full stainless steel housing that is certified for F&B, a splash zone. But at this moment, the so-called the F&B grade VeriSens, it is not certified for UR. So of course, if there is a need, we can actually get our factory to customize, just to load the firmware into the stainless steel model, so that it will be URCap certified. So we hope that this answer your questions. Okay, I see the next question. With this solution, could end user deploy themselves or need an SI to deploy? You want to take up this question?
Yeah, I can, Augustine. To be honest, although our robots arm are also is actually very easy to program, right? We do see quite a large numbers of our robots are actually require system integrator to build the entire solutions for the end users. We do have some end users are able to integrate vision system solutions together with our robots. But especially those that have engineering capabilities, we are able to train them to actually use how to use the UR robots. So it really depends on the capability of the end users. So what I see is, I think the if the capability of end users improve, right? We do see more and more end users able to do that. But today, to be honest, there's a lot of applications who still need system integrator help.
Thank you, X. Okay, we have someone typing now. Just give me a while. This one. Okay, we have one question. Can we use combination for guiding robot and some application in off one Baumer camera? It's you want to go first?
I'm not sure I
Combination.
understand your question correctly. You can actually
Combination.
use the hand guide function when you program the robots. But you can also use the Baumer cameras to actually provide a feedback to robots and tell the robot where is the offset, and then the robots will be able to take the offset and move to the right coordinates to pick up the items on, example, a random pick and place solution. Not sure that I understand Hui questions correctly over here. So in short, I think we can.
Okay, if from another understanding of your question, I will say that if my understanding is correct, so you are referring to whether the robots together with the vision system, the VeriSens, not only able to do pick and place alignment, uh, but at the same time uses the onboard VeriSens to do some visual check. So as if that's the questions, then the answer is yes. The VeriSens itself come with full-fledged the inspection tools of the VeriSens, okay, on top of the robotics alignment modules for the communication of the UR robots. So you can actually control if the VeriSens is mounted onto the UR robots, so you can control the robots to move the cameras to the right working distance, the right view to look at the object of concerns, and do the inspection. Of course, prior to that, you do need to teach the VeriSens to recognize the object, and depending on what is the type of inspection that you want to check, you have to teach the VeriSens accordingly. So I hope that is the answer that you're looking for in your questions.
Okay, this one is the question that Kelvin earlier asked about the foot grid. I think this is the question linked to the first question. In this case, the sensor cable, connector, and bracket, is it specially made for the continuous moving application? Maybe Augustine.
Yep,
you wanna touch
okay. For the VeriSens, when it's mounted onto the robots, both the process interface cables and the communication cables are robotic grade. So it is supposed to be able to withstand the frets, the multiple frets and twists in such application.
Just to add on what Augustine mentioned, in the UR Plus platform, there's also a, a guide, right? That is able to help you to do cable management. So that will help in terms of the entire you can see the entire application are monitored by using the cable management solutions that we have at UR Plus. Just want to add on over here, if you have additional sensors at the end of two flange where you mount your grippers and cameras and some other sensors, right? There's also additional IOs and power that's available at the two end over there. So if you does not need to route the cable all the way back, you can actually make use of the two end IO as well as power supplies, so that it's easier to manage in our cables. There's no twist cables as well.
Thank you, X. Okay, we have another one. What kind of protocol communication between Baumer and UR?
I think this, Augustine.
Okay. Because the communication wise is actually based on the backbone is based on TCP/IP, and the communication and the actual language, okay, or the communication code is already so-called in sync. So the moment you select under the Vision VeriSens URRobots communication protocol, the VeriSens itself will automatically switch to the right language to communicate with the URRobots. So you do not need to handle the portion of the communication between the VeriSens and the URRobots.
I think that's a beautiful part about URCap to make it make both solutions integrate much seamlessly in a sense, right?
Yes.
Okay, let me see whether is there any more questions. We have one. Do we need to consider the lighting in the area, color of the object being detected related to the sensor detection capability?
Okay.
I think.
Let me take up these questions. In terms of the lightings, the VeriSens offer two type of models. Okay, the SF900, which come with built-in lens and lighting. So the lighting portion has really been taken care by the built-in lightings. If the solution is incorporated with the XC900 series, which is the C mount, then a external lighting has to be installed together with this C mount lens. So the lightings can be connected back to the VeriSens. The VeriSens SC series come with built-in light controller to power the light and also to strobe the light. So turn on and turn off the light during the capturing process. So in terms of the color of object, so currently both the SF and SC900 series URCap certified monochrome sensors. Okay, so it doesn't recognize the colors at the moment. Of course, if you need to do color pick, there are ways to use the lightings to illumine the various color object for the VeriSens to differentiate them. So I hope that's the answer you're looking for.
I think someone have helped me to answer the questions. We don't run as fast as these SCARA robots or 4-axis robots, right? So universal robots, we do specify the two flange speed. So where you mount your grippers, where you mount your cameras, if you mount it on the two flange, right? We actually specify the robots can actually move linearly from point A to point B is at 1 meter per second. So generally kind of mimicking what humans are doing in terms of very similar kind of speed that we can do. But if you want to compare with SCARA robots, definitely we are not running at very high speed compared to SCARA.
Okay, any more questions?
I don't see any more.
Yeah.
A lot of questions already. Yes.
Okay. So that brings us to the end of the webinar. Thank you all for attending. We hope you have learned and enjoyed this presentation. If any of you have any question after the webinar, do feel free to contact Baumer or UR. We will come back to you as soon as possible. Lastly, this is the survey form we need you to fill up. Just give me a while. I will flash this one out. We need some feedback from your side. Okay. I hope you can see my screen. We need to know the response. So will you be interested to see vision system with cobot live demo? So you can click on yes, the picture there, or no. Yeah. Okay, we give another 2 to 3 minutes for the rest to fill in. Okay, we have some people actually still doing the survey. Okay, so I end the voting. Thank you for voting this. Okay, next, we would like, give me a while. Yeah, this is the survey form. I need your help to actually fill in. Your view is very important to us. It helps us to actually improve ourselves for our next event. So please help us to fill in this survey form. And thank you. We shall see you all again. Stay safe. Goodbye.
Thank you very much. Stay safe, everyone. Bye bye.